Hi there. I am going to give a brief demo of some quantitative univariate summarization and plotting. So the first thing we're going to do is load Tidyverse and load the Palmer Penguins library, which has some penguins data we're going to use. So once we do that, let me just go over here. Okay. Okay. Oh, right. Load those libraries. Sorry. And then I'm going to load the data. You'll see up here that at first it says promise. If you open up the console here and you start typing penguins, it'll then be available for you to use. So start typing that and then delete it. The first thing we'll do really quick is just open up this data set. So we see that there's some variables: species, island, bill length in millimeters, bill depth in millimeters, flipper length, body mass, sex, and year. So we're just going to do a little bit of exploration just to kind of give you a quick example of writing some code. So the first thing we're going to do is look at the distribution of bill length in millimeters, and we're going to do this by creating a histogram. So in order to do plotting in R, or at least how we're going to do it, we're going to start with the ggplot function. And we have some options for how to write this code. I'm just going to write it with the aesthetic mapping right there, that AES function. This is where we map variables to different aesthetics. So in this case, on the x-axis, we want to put that variable bill length mm. And then after that, I'm going to put a plus sign. And I now need to tell it what kind of plot to create or what type of geom to use. So this is a geom histogram. So we're going to be creating a histogram. I don't know why that red X is there. Sometimes they're there by mistake, which looks to be the case here. So I'm going to run that code. Oops. Oh, that's what I did. Hello. Well, good job, Lisa. Way to make a mistake right away. I forgot to tell it what data I'm using. That's a good mistake to make. So I'm going to use the pipe notation here. Again, we do have a couple of options, but I'm going to use penguins and then the pipe, which is percent greater than percent, or you can use the shortcut of Command Shift M or Control Shift M on a Windows machine. And just to make my code look nice, I'm going to press enter there. And let's try that again. That looks much better. It will give you a little message here saying a couple of things. So this is saying that it's using 30 bins, meaning there's like 30 different breaks. And we can change that. And then it's telling you that it removed some data because it didn't have non-finite values, or it had non-finite values. In this case, those are missing values, which are coded as NAs in this data set. And we can see them. There's one right there. Okay, so it's just letting us know that it removed those. And that's good to know. Okay. And then the other thing, what I'm going to do here, this is okay. This is a great start. I'm going to now copy that entire code chunk down here. And I'm just going to show a couple different things we can do here. So inside of geom histogram, not inside the AES function, I'm going to change the number of bins to 50, which I think is going to end up being too many, but I'm going to do it anyways. And I'm also going to change the fill. The fill is how the bars are filled in. And I'm going to change the fill in color to orange, which is likely a terrible color, but I'm going to do it for now anyways. Okay. Now notice here, this is not inside of that AES, the aesthetic mapping. This is because, think of it as changing a setting, right? I just want to change the color or the way this is filled in to orange. I am not mapping a variable to anything. Also notice that with 50 bins may end up being a little bit too many. It doesn't really look like we're learning anything new from 50 bins. So I encourage you to sort of play around with this a bit. 20, I think, is too few. We do seem to be missing some details, so perhaps I'll just stick with 30. Okay, we are going to describe our distribution in just a second. But before I do that, it's helpful to have some summary statistics here. So things like, perhaps the mean and standard deviation. Perhaps we'd want to know the median and the interquartile range. Those are two sort of different sets of statistics that can help us describe the shape, the center and spread of the distribution. So let's start by taking the penguins data, and then anytime I use the pipe, I will say, and then I'm going to summarize my data. And when I summarize, I have to specifically tell it how to summarize the data. So in here on the left, I'll put the name of the new variable. So let's call this bill mean. And I'm going to take the mean of bill length Now, I'm going to stop here. I just want to show you really quick that when I do this, you might think that this is wrong. But what's happening is because I have missing values in the data, it is returning a missing value for the mean. But I can fix this inside of this mean function. So notice I'm inside of this first closed parenthesis, which is still inside of that mean function. I'm going to take the mean of bill length, but I'm going to add another argument to this function. So I'm going to add a comma, and I'm going to put na.rm. I wouldn't expect you to know this yet. This is one of the arguments I can put inside this function. That stands for remove NAs, and I'm going to set that to true, capital TRUE. It has to be all capital letters. Now notice when I do that, it does actually return a number. So this is the mean with those missing values removed. So now that we know how to do that, I'm going to also compute the standard deviation, which uses that SD function. And I'm going to cheat a little bit, and I'm going to copy and paste that inside part in here, because I'm going to be taking the mean or the standard deviation of that same variable. And I also want to get rid of missing values. And then just to show you, so this would be good enough to describe the center and spread of our distribution, but I'm also going to compute the median. And once again, paste that in there, and I'm going to compute the IQR. The IQR, the interquartile range, is the difference between the 75th percentile and the 25th percentile values. So oftentimes we use the median and IQR to describe a more skewed distribution, one that's not symmetric. And we often use the mean and standard deviation when we have symmetric distributions, but that's not always the case. So here, if we're going to describe this distribution, I might describe this as multimodal. It's at least bimodal, perhaps trimodal, with one of the centers near, just under 40 millimeters and another one around 50 millimeters. And then I might say, the overall mean is 43.9 millimeters, and the standard deviation is 5.46 approximately. That should give someone a fairly good idea of what the distribution looks like. We can also create density plots. So I'm going to do one of those here, and I'm going to go ahead and steal some of my code. So I'm going to copy this. I'm a big fan of copy, paste, modify. And I'm going to put that code right here because I still want bill length on the x-axis. I just want to change the type of geom I'm doing to a density plot. So a density plot is like a smoothed out histogram. So I'm showing you this here, although I don't think it's really a good time to use the density plot. It's probably smoothing this out too much. Our data set only has 344 observations. I would use this sort of thing when I have a lot more data, and I typically will start with a histogram and then move to a density plot if that seems appropriate. Okay, I am going to stop recording, and hopefully that was helpful.